In this podcast, again, this kind of looks like the Day 3 podcast. We're going to review the different rules that we've been looking at for 3 days now. And our activity in class will be to find the error. So let's start with the first one, product rule. So by now you should know that 109 to the 11th times 109 to the 4th is 109 to the 15th power. The rule is if they have the same base, you're going to add the exponents. If they have the same base and you're dividing, you can subtract the exponents. If you had 7 12s on the top and 3 12s on the bottom, cancel. You'd have 4 12s left on the top. So this is a to the m minus n power. If you have a negative exponent, you can flip it to the opposite spot and make it positive. So I should make that 3 positive. If it's negative on the bottom, flip it to the top and make it positive. So I call it the flip-flop rule here. The negative exponent rule, flip-flop. This is 1 over a to the n. The zero exponent rule, anything to the power of 0 is 1. And a power to a power rule, you multiply the exponents. This is a to the mn. Okay, so with those in mind, again, we're going to do, I think, 10 examples. And these ones are a little bit different than yesterday because we have a lot more negatives. So let's take a look at this. This is negative 5x squared. And if you forget what this means to do, write it out. This means negative 5x times itself, negative 5x. A negative times a negative is a positive. And then we have x times x is x squared. Now, if you were to put this in your calculator, remember we're distributing, this would be a negative 5 squared. Put parentheses around the negative 5 to tell the calculator to square the negative 5. And then you'll get the positive 25. Okay, so don't forget those parentheses. All right, the next one, power to a power, so we multiply, this is t to the negative 30, but again it's negative. So you want to rewrite the exponents, they're positive, this would be 1 over t to the 30th power, the flip-flop rule. Let's look at the next one. We have b to the 9th times b, and this would be to the first power. So if a number's not written, it's really to the first power, times b to the 5th. Let's add these guys up. We have b to the 15th power. Add the exponents if the same base is being multiplied. All right, this one again, if you forget what it means, write it out. All right, a negative times a negative is a positive. But then times another negative keeps it negative. So this is negative a to the 3rd power, and we have 3 b's, so this is b to the 3rd. So here's the answer. Basically, if you have a negative on the inside of the parentheses, and if you have an odd number here, the answer will be negative. Because each positive, each even number set will make it positive, and you're going to always have, if it's odd, one remaining thing that will make it negative. All right, the next one, 1 over x to the 5th times x to the 8th. That's the same as saying x to the 8th over x to the 5th. We have 8 x's on top, 5 on bottom, so when you cancel, you have 3 left on the top. So this is x to the 3rd power. This negative's on the outside, so let's do that one last. Let's distribute. We know anything to the 0 power is 1, but the negative's on the outside. So this isn't a positive 1, it will be a negative 1 for your answer. All right, let's take a look at number 7. Power to a power. This is g to the 15th power. You multiply. The next one, okay, so here's an example of a negative to an even power. So this will be 2 to the 6th power. But now it's a negative to an odd power. So this will be negative 2 to the 3rd power. And we have the same base here, so you're going to think there's 6 2's on top and 3 on bottom. When you cancel, there's 3 left on top. But again, that negative makes the whole thing negative. So here's your final answer. If you type that in, 2 to the 3rd power is 8. You could also write this as negative 8. Okay, let's try the next one. Distribute the negative exponent 4 to the negative 3, x to the negative 15. All right, to make them, if the exponents are negative, to make them positive, you flip it. So this is 1 over 4 to the 3rd power, x to the 15th. You can simplify it further. 4 to the 3rd power is 4 times 4, which is 16, times another 4. So let's do that here. So your final answer could be 1 over 64 x to the 15th. And the last one, we have negative 5 to the third power, g to the third power. And again, this negative 5 means negative 5 times negative 5 times negative 5. I believe that's negative 125, g to the third. Okay, so if you have a negative base to an odd power, it will be negative. If you have a negative exponent, you flip it to the opposite spot to make it positive. So on today's assignment, again, we've added just one more thing, more negatives. But if we look at the assignment, if it would let me click on it here, it says 4 of the following statements are incorrect. If incorrect, identify the mistake and show the correct reasoning. If correct, justify or show why it's correct.